All right, let's start at the beginning. So what are we checking to see for it to have an inverse if it's the graph? What does it have to pass? Horizontal line test. So does A pass your horizontal line test? No. So if I ask, does it have an inverse? I also would ask, is the graph one-to-one? Those mean the same things. Or is the function one-to-one? Okay, those mean the same things. How about 2? Does it have an inverse? No. Okay, it would also fail your horizontal line test. How about 3? Yes. Okay, then when I get to the equations, what are you looking for? When does it not have an inverse? Good, if x is raised to the even power, or x is an absolute value. So does 4 have an inverse? No. Does 5? Yes. Good. Then we find the inverse. So what's the first step? Make f of x y, switch the y and the x. And then I got to isolate that new y. So I can subtract the 5. X minus 5 equals 2y. Divide by 2. And then make sure you do the f negative 1 of x. That will cost you points if you don't do it. Make sure it does that. You could leave it this way. You could leave it this way. You could leave it this way. Any of those are good. But the f negative 1 of x has to be put back in at the end. Questions? Okay. So like I said, we're going to start chapter 2, section 1, which is quadratic functions. We'll finish it tomorrow. This homework will be due on Wednesday. So it's all one homework that you can break apart. If you wait and you do it tomorrow, you're going to hate life. I'm going to warn you that. It's long. They take a little bit of time. So I would say definitely start with what you can tonight and then carry it on until tomorrow. So we are going to spend a whole bunch of time talking about quadratic functions. Okay, this is everything you ever thought you wanted to or not wanted to know about a parabola. So we start with what is the function equation. Anything that's got an x squared is going to be a parabola. There are 2 forms of this equation. Quadratic form, which is what this is, and then standard form, which we're going to talk about. Quadratic form will have an x squared and an x. That's how I know it's in quadratic form. And then standard will be like x in parentheses squared. You won't have both the x and the x squared. The graph is called a parabola. It is shaped like a U. It is symmetric to a line called the axis of symmetry. So the line that runs vertically through your vertex is called your axis of symmetry. If the term on the front of your x squared is positive, then my parabola opens upward. And if it's negative, it opens downward. All stuff we already know, hopefully. We're just going to get way more specific than we did when we did our transformations. The vertex is where your graph changes from increasing to decreasing, okay? Or decreasing to increasing. It's where it changes direction. That would be a coordinate point. We call it HK. The axis of symmetry is the line that runs through that point. It is vertical, so this has an equation. It will be an x equals, and it is x equal to the h coordinate of your vertex. That has to be an equation. If you just wrote what h is, that's wrong. It has to be an equation so that it knows to be a vertical line. And then your graph will either have a maximum or a minimum. It will have a maximum if it is a parabola that points down, and if it will have a minimum if it is a parabola that points up. That max or min is your vertex, technically the y coordinate of your vertex. So if I gave you an equation or I gave you a graph, you should be able to tell me the axis of symmetry, the vertex, the maximum, the minimum. We're going to get into intercepts, domain and range. All that stuff can come from this section. Anybody still copying that down? Okay. All right. So this first one kind of leads out of our transformations. This says graph the parabola by plotting points. So we're going to plot one point using our transformations and then add whatever points we need to. So tell me what you know about this graph based on prior knowledge. It's a parabola. What are my translations? One to the left, right? And what's the 2 on the front do? It's a vertical stretch, or it makes it narrower. So the first thing I can find is my vertex by shifting to the left one. So I know that's my vertex. Vertex, negative 1, 0. Now, if there was no stretch or shrink, then I can go up 1 and out 1 in either direction, and I could plot my parabola. There is a stretch this time, so I'm going to take and plug in 1 point to the left of my vertex and 1 point to the right of my vertex. So if I make x negative 2, then I get 2 times negative 2 plus 1 squared. 2 times negative 1 squared, 2 times 1, which is 2. So when x is negative 2, y is 2. It has a vertical stretch of 2, which makes sense. Then I'm going to plug in a point to the right where x is 0. And I'd get 2 times 0 plus 1 squared, 2 times 1 squared, 2 times 1, which is, again, 2, which should make sense because this has symmetry through, like, to the line that runs through my vertex. So you only need those 3 points. 3 points makes your parabola. So easy to do is find your vertex and then plug in a point to the left and plug in a point to the right. If you do it correctly, then it should mimic whatever it is stretch-wise you said should happen. So from here, I could ask you your vertex. I could ask you your axis symmetry. I could ask you domain and range. I could ask you minimum or maximum. Like, all those things can come from every single parabola. Questions so far? All right, now if it's in standard form, it looks like this. F of x equals a times x minus h squared plus k. The a on the front still does the same thing as before, either flips it up or down, stretches it or shrinks it. The h is going to be your horizontal shift. The k is going to be your vertical shift. So that vertex is your hk, and your axis of symmetry is x equals h. Now, when we are graphing using the standard form, we would follow these steps. We'll determine if the parabola opens upward or downward based on my a value. We would find the vertex, which is your hk. We would find intercepts. So for our x-intercepts, we're going to plug 0 in for y, and for our y-intercepts, we're going to plug 0 in for x. Now, when I plug 0 in for y, it will, if it's in standard form, I can just solve it. If it's not in standard form, we're going to have to factor or use the quadratic, which we'll come back to. And then you're going to plot your intercepts, your vertex, and any additional points if needed. So we're going to see if by getting our intercepts and our vertex, that's enough information to plot our parabolas. All right, so let's do it that way now. Graph the quadratic function f of x equals negative x plus 2 squared plus 4. So we're going to start by identifying if this function opens up or down. Which one is it? Downward, because the a on the front is negative. Then my vertex, I change the sign of what's inside here because we'd go left 2. So my vertex is negative 2, and then I keep this sign because it's a vertical shift up 4. So negative 2, 4 is my vertex. That also means I can determine my axis of symmetry. So I'm going to do AOS for axis of symmetry. And it is an equation. It is x equals my h value, which in this case is negative 2. So I have an axis of symmetry running through my vertex. Now, if it didn't ask for intercepts and that kind of stuff, I could literally just plot a point to the left and to the right, and I could close in my parabola. But there are going to be times when it asks for the intercepts, so we're going to do them. The y-intercept is the easy one. I plug 0 in for x. So I get f of x, or y, equals negative 0 plus 2 squared plus 4. I get negative 2 squared plus 4, which is negative 4 plus 4, or 0. So my y-intercept and an x-intercept is 0, 0. Now, based on that axis symmetry, where do we think our other intercept is going? Negative 4, right? It's going to be reflected over, but we're going to check it with our work. But if you use your axis symmetry, it saves you time. So our x-intercepts come by making f of x 0. So I get 0 equals negative x plus 2 squared plus 4. And now I'm going to solve for x. So I'm going to subtract the 4. Before I can square root, I've got to get rid of this negative. So I either divide or multiply by negative 1. I get 4 equals x plus 2 squared. Now I square root both sides. I got to put a plus and minus in front of the root on the 4. So I get x plus 2 equals plus and minus square root of 4, which is 2. Now that's plus and minus, right? Which tells me I have 2 answers here. I'm going to continue to solve this where one of them has it equal to negative 2 and one of it is equal to positive 2. Subtract that 2 and I get x equals negative 4. Subtract the 2 and I get x equals 0. So I have 2 x-intercepts. Negative 4, 0, and 0, 0, which was consistent to what I thought was happening on the graph. So then I use those two to finish my parabola. Questions so far? So your quiz is going to have like multiple parts on one question. It's going to say find the vertex, find the axis symmetry, find your x-intercepts, find your y-intercepts. It could ask for max and min, all those things, and then it will ask you to graph it. It could ask you for domain and range, and then it will ask you to graph it. Still with me? Yeah? Everybody's good? Yes? Okay, you do it. All right, you should get this, right? So our shifts are to the right, 3 down, 4. So our vertex is 3, negative 4. Your axis symmetry is x equals 3. When you find your y-intercept, you plug 0 in for x, you get 5. When you find your x-intercept, you set it equal to 0, and you should get both negative or 1, 0, and 5, 0. These should be symmetric. So if I'm going up and then I go to the right 2, I should also go up and to the left 2. So all those things allow you to check to make sure that you did the right thing. The parabola should point up. We know that from the beginning. Questions on any of those? What would the domain of this function be? Negative infinity to positive infinity, all real numbers. And the range? Good. Negative 4 with a bracket to positive infinity. Questions before we move on? Okay, so those started in standard form. Those last 2 examples started in standard form, okay? What happens when it doesn't start in standard form, we're going to have 2 options. And one is to force it into standard form. So if your question says, here's your function, and it's written as an x squared and an x, like in quadratic form, and it says put it into standard form, then we go through a process called completing the square, okay? Completing the square is one of those skills that you are going to use from now until literally chapter 9. Like chapter 9 is conics, and in conics we complete the square. So it is one of those skills you're going to do on repeat. You want to master it, okay? So the way we complete the square, the first thing we're going to do is take whatever our ax squared plus bx, and then we're going to group those together, and we're going to bump the c to the outside. If there's a number on the front of the x squared or a sign, so even if it's just a negative, or there's a sign, we have to take it out. So by taking it out, we're going to put the a on the front. We're going to factor it out of the x squared and also the b term. So if I take out a 2, let's say, then I divide both the x squared by 2 and the bx by 2. Then I have to complete my square. So we're going to leave a space here, and we got to figure out how to fill that space. To do that, we take our term. That's our second term inside the parentheses. We divide it by 2. Then we square it. So if that middle term was 4, well, let's say 6, for example, then I would do 6 divided by 2 is 3. 3 squared is 9. And then I'm going to add that term inside the parentheses. And to balance out this equation, we're going to subtract it from outside the parentheses. Now, when you do complete the square in other ways, if we do complete the square to solve an equation, then we can add to both the right and the left side of the equation. When you get to this step, I'll make more sense of it. But in this case, we want to keep everything on one side. So we're going to add inside the parentheses, and to balance out that equation, we're going to subtract outside the parentheses. Did you have a question?
Yeah. Why isn't C divided by A?
Because you're taking it out first. So that's why we group these together first.
So you're just dividing it in the group?
Yep. And then, because there is a way to do that, but then this method, and then when we factor this out, the A is only on the front of this part of my function, and the C is not affected by it, if that makes sense. Yeah. So what will happen is if you, I don't know what's happening there. Okay. If you factor something out, so if I've got something on front of the x squared and my bx, now this is divided by a, and I've added something here and I've subtracted it from here. So whatever I add here, I'm going to subtract, well, let's call it d because we're adding something different. I would subtract it from here. When I do that, if there is something on the front of the A or something on the front of the parentheses, I have to multiply it by that term before I add it or subtract it from the end. And that is taking care of C dividing by A, if that makes sense. If you divide everything by A in the beginning, you don't have to do this step, but we want to keep it inside the parentheses like that. And then we will take what we just made, which is a perfect square trinomial, and we will factor it. When you factor a perfect square trinomial, we square root the first term. We square root the last term. We take the sign from the middle. We put it in parentheses and square it. So we will have made a perfect square trinomial. We will then factor it, and then your function is going to be in standard form. So we're forcing it into standard form. So every time you see on WebAssign, it says, here's your function, put it into standard form, it means complete the square. This is how you'll do it, okay? So we're going to practice this a couple times.
Do we have a lot of?
There's, yeah, I think there's 3. And this is also, if you go to chapter 2, that top part where it says the prereqs, remember like we did on chapter 1, I have that page that has all the prereqs. There's a whole section on complete the square. Okay. Yeah, because it is that you are going to have to master. All right. Well, we're going to change that. All right. So it says write the function in standard form. Again, AKA complete the square. And then we're going to go through all the parts that we already did. Identify the vertex, axis, symmetry, intercepts, and graph. So first thing I'm going to do is take this function. I'm going to group the first 2 terms. If there was something attached to the x squared, we would take it out. We're going to baby step our way into that. There's nothing attached to the x squared. So I'm going to leave a space for what I have to add here. And then to find that term, I take b. b is technically negative 14, but I'm not worried about the sign right now because I'm always going to square it. So it's always going to go back positive. So I take my 14, I divide it by 2, and I square it. And 14 divided by 2 is 7, and 7 squared is 49. And I add it inside the parentheses, but I have to balance the equation, so I subtract it outside the parentheses. Now I've got x squared minus 14x plus 49 plus 5. And I just made that parentheses into a perfect square trinomial. So the shortcut to factor, square root the first term, square root the last term, take the sign from the middle, put it in parentheses, and square it. And now my function is in standard form. That's step 1, okay? And there will be a question on your quiz in which you will have to put it into standard form, because I'm going to teach you another way to graph these, but there's times when you have to put it into standard form. All right, so now tell me what you know about this parabola. Good. It's right 7 and up 5. So there's my vertex. Which way does it face? Up. okay? Because it's a positive a. So if I just started with that information, right 7, up 5, I know it points up. So I don't know right now exactly where I'm going, but I'm going somewhere like that, right? What does that tell you about your x-intercepts? They don't exist. So let's say we didn't know that. We would set it equal to 0. We would subtract the 5, and I'd get negative 5 equals x minus 7 squared. And I'd go to square root, and what happens when you go to square root negative 5? Can't. It's an imaginary number. So I would say no x-intercepts. Where's your axis of symmetry? X equals 7, right? So it runs through here. So it's not going to point down, which means it's not going to have x-intercepts. My y-intercept, there's a reason it doesn't ask for it, because and here's what I would say you definitely want to learn. When you are finding your y-intercept, you can plug a 0 in here to find your y-intercept, but it is much easier to plug a 0 into here because both of those x terms disappear. And my y-intercept would be 0.54, which is why I didn't ask for it, because I don't want you to graph something that says 0.54, okay? So then the next thing I would do is A, plug in numbers, or B, understand your graph. Is there a stretch on this graph? Is there a shrink on this graph? Which means I go from my vertex up 1, out 1, up 1, out 1 in either direction, and I can draw my graph. You could also have plugged in 6 and 8, 1 to the left and 1 to the right. But if you understand your stretch and shrink, then you don't need to do that. Questions so far? All right, we're going to do one more, and then we'll stop for today. This is where it gets messy. Same set of instructions. Write the function standard form. Identify the vertex, axis of symmetry, x-intercepts, and graph. So if I start at the beginning, I'm going to group together the first two terms. This time, what's happening?
You have to divide out the 2.
Good. There's something on my x squared term, so I have to take whatever's there and divide both these terms by it. So 2 goes on the front. It doesn't go away. It goes on the front. So I'm dividing both the a and the b by it, which means this is x squared, which is what I want it to be. But b becomes negative 3 halves x. I'm going to leave my space because I still need to fill it in. And then add the one after the parentheses. You with me so far? Yes? So what do I do to fill that space in? Take that second term, divide it by 2, 3 halves, divided by 2, and then I have to square it, right? So dividing by 2 is the same thing as multiplying by a half. 3 halves times 1 half is 3/4. And then I'm going to square it, and I get 9/16. I'm going to add the 9/16 inside the parentheses. And normally I'm going to subtract the 9/16 from outside the parentheses to balance it out. But because I have taken something out of this parentheses, I have to multiply it by that term before I combine it with the one on the outside the parentheses. So then 2 goes into 16 8 times. So from that positive 1, I am actually subtracting 9/8. So if you take something out, you have to multiply it by the opposite of what you add into the parentheses, because we normally add it and then subtract it. We're going to multiply what's on the front by it before you combine it. So then I have 1 minus 9/8, or 8/8 minus 9/8, which is negative 1/8 on the outside of the parentheses. 2 is still on the front, and be careful there because a lot of people will forget that too. And then I'm going to square root the first term. Square root the last term. This square rooted is also the same thing as this guy before we squared it. Okay, if you want to save yourself some extra work, but it's 3/4. We take the sign from the middle, which is minus. We put it in parentheses and square it. So yes, you are going to get things you have to take out. Yes, you are going to get yucky numbers that are not going to divide evenly. Okay, so now my vertex is what? Good. 3/4 and negative 1/8. What's my axis symmetry? X equals 3/4. So 3/4 and negative 1/8 is something like that. This time there is a stretch, so I can't just go up 1 and over 1. And I don't know that I'd want to because it's a fraction there. It's not going to be as easy to find those spots. So this is where all those other things come into play. If I wanted to find my x-intercepts. Now, again, I have two options. And to be honest, I switch back and forth depending on if my original function is factorable. If my original function is factorable, then I go back to the original one to find my x-intercepts. I factor it, and I find them that way. If your original function is not factorable, then you can solve this guy. You just have to square root fractions, which it works. You can do it. You might have to rationalize, which it gets messy. So I would always come back up here and check to see if that's factorable first. So when there's a term on the front, I do first and last. Like you could do trial and error, but I do first and last. So I multiply 2 times 1, I get 2. Are there factors of positive 2 that sum to negative 3? Negative 2, negative 1. Yes, so I know this is factorable. So I'm going to say 0 equals 2x squared minus 3x plus 1. And I'm going to factor it. You can either do first times last or trial and error. If I do 2 times 1, I get 2. Factors of 2 that sum to negative 3, we just said negative 1, negative 2. Replace your middle term with those two terms and factor by grouping. Take out an x. Take out a negative 1. And I get 2x minus 1 and x minus 1. Now I split and solve, and I get 1/2 and positive 1 for my x-intercepts. In this case, would it be easy to find your y-intercept? Yep, come back up to the beginning, make both those x's 0, and what's your y-intercept? 1, good. So I know it's here, it would reflect over here, I could draw my parabola. Let's say from the beginning it wasn't factorable, or even if it is, but you just like the quadratic formula, don't forget that that's always an option. So if it starts quadratic, negative b plus and minus the square root of b squared minus 4ac over 2a is the other way to solve this if you set it equal to 0. Or, again, I'll walk you through this process. You only have to do one of these three, though. If I set this equal to 0, when it's in standard form, then I'm going to add the 1/8. I get 1/8 equals 2x minus 3/4 squared. Divide by 2 or multiply by 1/2, and I get 1/16 equals x minus 3/4 squared. Square root both sides, and I get plus and minus 1/4 equals x minus 3/4. And I split and solve it. Negative 1/4, positive 1/4, add the 3/4. Add the 3/4. And I get 2/4, which is 1/2, and 4/4, which is 1. So same answer can be found. Factoring, I think, easiest. If it can factor, we'll do it factoring. Second would be the quadratic formula, probably. Third would be setting it equal to 0 if there are fractions involved. If there's not fractions involved, it's not so bad to do it that way. But you've got options when it comes to that kind of stuff. Questions on that one? Again, we're going to stop there today. So like if you go through your WebAssign, you're going to see there's parts that you can do already. I would strongly recommend you start. I think the standard form ones are at the end. So feel free to get to those and save your progress.